In this video, we want to solve for a. Here we're gonna have 2 to the power of a plus 4 can be written as 2 to the power of 2. Here we have to the power of a equals to 8 can be written as 2 to the power of 3. And here we have the a. Now, recall that if you have 2 to the power of x and y, it's the same thing as 2 to the power of x times y. So I'm going to use the same approach here. So this is going to be 2 to the power of a plus 2 to the power of 2a equals to 2 to the power of 3a. Now we can write this as saying 2 to the power of a plus 2 to the power of 2a minus 2 to the power of 3a equals to 0. Now let's factor out 2 to the power of a. So in the parentheses here we can have 1 plus 2 to the power of a minus 2 to the power of 2a equals to 0. Also, recall that here if you have 2 to the power of a multiplying 2 to the power of a, from the law of indices, this is going to be 2 to the power of a plus a, which is 2 to the power of 2a. So this is what I did by factoring out 2 to the power of a. Now, let 2 to the power of a be equals to y. Now, one thing you have to take note of here is that since 2 to the power of a equals to y, then you're going to know that y must be positive. Y must be greater than 0. And also, we have that y is not equals to 0. It is never possible for the value of y to be equals to 0. And also, it is not possible for the value of y to be negative. Now, for you to plug in that, if you plug in y into the previous equation, you're going to have y into parentheses 1 plus y minus y squared. So we have this to be equals to 0. Here, you can say that y is equals to 0, and in this case, you can say that 1 plus y minus y squared equals to 0. So here I'm going to say y1 equals to 0, and here you can say that if you multiply this through by negative, you're going to have y squared minus y minus 1 equals to 0. Here, you see that this is impossible. So you have to remove this. Why? Because in the previous slide, we have the condition that y is greater than 0, and we have also the condition that y is not equals to 0. So this is not part of the root of the equation. So now we have to deal with y squared minus y minus 1 equals to 0. Solving this quadratically, by writing out the coefficient, you can say that a equals to 1, b equals to negative 1, and c also is equals to negative 1. Here, using the quadratic equation, recall from the formula of quadratic formula that y equals to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. Now let's plug in what we have. Here we have y equals to minus b, which is negative 1, plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a. My a is 1 and c is negative 1. Everything divided by 2 times a, which is 1. So here, y is going to be negative multiplied by negative is going to be 1, plus or minus the square root of negative 1 squared is 1. Negative times negative is going to be plus 4 over 2. So here we have y. Let me call this y1, okay? So my y2 is going to be 1 plus the square root of 5 over 2, and my y3 is going to be 1 minus the square root of 5 over 2. Now, if you have a very good look at this, you can see that this also is not valid. Why? Because the square root of 5 is like greater than 2. So 1 minus 2 is going to make this to be negative. And if you recall from the given condition of y, that y is greater than 0 and also y is not equals to 0. So that means y3 is invalid. So we deal with y2. So here we have our y2 to be equals to 1 plus the square root of 5 over 2. And recall that we have 2 to the power of a to be equals to y. So now we're going to plug in the value to that. So here we have 2 to the power of a equals to 1 plus the square root of 5 over 2. Now, to simplify this further, here we can apply logarithm to both sides. So here we're going to have log 2 to the power of a equals to log 1 plus the square root of 5 over 2. Now, moving this a behind the logarithm. Okay, so here we have a log 2 equals to log. You can rewrite this because when you have log a over b, it's the same thing as saying log a minus log b. So here we can have log 1 plus root 5 minus log 2. Now here, dividing both sides by log 2 to get a, the coefficient of a. So here we're going to have log 1 plus the square root of 5 minus log 2, everything divided by log 2. And also, I want you to know that when you have a minus b over c, it's the same thing as saying a over c minus b over c. So they can both share the denominator. So here we have a equals to log 1 plus root 5 over log 2 minus log 2 over log of 2. So here you can have this cancelling out, okay, to give 1. So next we have a to be equals to log 1 plus the root of 5 divided by the log 2 minus 1. If you solve this by plotting this value in a graph or by simplifying this further, approximately you're going to have the approximate value for a, which is 0.694. So this is what we have been able to do. If you have an alternative method that is more proficient than this, please you can kindly put it in the comment section. Thank you very much for watching. See you next time.